Hey Comets, welcome to another day of learning. Today we're going to be looking at the second page of the packet that came out or is supposed to come out on April 27th. So the page I'm looking at looks like this. It says combining like terms to simplify expressions. In our last video we looked at evaluating expressions and simplifying expressions. Okay, now we're going to go into combining like terms to simplify algebraic expressions. So like terms are two or more terms that have the same variable raised to the same power. And a lot of times I'll say the same variable cluster. Okay, so if that variable or that variable cluster looks the same, then they are like terms. Okay, it doesn't matter what the number in before it is, we call that the coefficient. As long as they have the same variable or same variable cluster, they're like terms. Okay, so in the expression 3 plus 4x squared minus 2y plus 2x squared plus 3y plus 5, the like terms are marked with the same shape. Okay, so look at these trapezoids. These are like terms because they do not have a variable. Okay, so you can not have a variable and be like in that way. Okay, so for example, before I had a smartphone, I would be like someone else who didn't have a smartphone because we had that in common. We didn't have a smartphone, okay? So you can be alike without having a variable, all right? Also, x squared, there's another x squared here, okay, in this rectangle, all right? And then finally, our y's, we have a minus 2y and a plus 3y, they are alike, so they're in the circles. Okay, when terms are alike, we can combine them to simplify an expression. So let's combine the like terms inside our shapes. So look what they did. They took the 3 and the 5 and they added it together and they got 8. Okay? And then they took the 4 in front of the x squared and the 2 in front of the x squared and added that together to get a 6x squared. Okay? So notice you just add the numbers in front and then combine it like that. Then here we have the minus 2y and the plus 3y and they get a 1y. Now think about that. We haven't talked about negatives yet. But if we took 3 and subtracted 2, we would get 1. And that's where that 1y comes from. All right? So our final answer is 8 plus 6x squared plus 1y. All right? And there's no other like terms that we can combine. We are done. Okay? So don't go too far. You cannot combine this 8 and this 6 because they do not have the same variable or variable cluster. All right? Same with these two. So let's look at one together. Combine like terms, whoops, zoomed out, didn't mean to do that. Oh well. 2x plus 3x minus 4.5x. All right? So let's take a look at that together. All right, I've got 2x plus 3x minus 4.5x. All right? Let's take a closer look at that. So I've got 3 terms, okay? Because my terms are separated by addition or subtraction signs. So I've got 2 separation things, so I have 3 terms. So I have a 2x, 3x, and 4.5x. So what are the like terms? Well, they're all like terms. They all have the same variable, in this case, x. All right? So I've got 2x, 3x, and 4.5x. So let's add these two together first. The 2 and the 3 come together, and I get a 5x. Okay, because 2 plus 3 is 5. And then I'm going to take this 4.5x and take it away, subtract. So I have a 5 minus 4.5. Okay, that's going to be 0.5. Okay, I could try that on a calculator, but for time's sake, we'll just go with that. All right? So 5 minus 4.5 would be a half, or 0.5x. And that would be my answer. I cannot go any further than that. All right? Now, let's look at another example. Okay, what would be another good one to look at? Tell you what, let's look at this one right here. Okay? All right, this is E. Looks like 5x plus 2y plus 1/3 x squared minus 3x. Okay, now it looks kind of scary, all right? Well, let's take a closer look at this scary looking problem. All right, do we see any like terms? Okay, well this 5x kind of looks the same as this x squared, But since this is only x and this is x squared, they're not like terms. Okay, the x and the y, they're not like terms. So really the only like terms we got is this 5x and this minus 3x. Okay, so I'm going to combine those. So 5 minus 3 would be 2x. And then I can't do anything with the rest of this. So I'm just going to rewrite it just as it is. Can't change it. And then, believe it or not, that's it. Okay, that's as far as I can go on this problem. All right, so that's my final answer. Okay, so combine the like terms, terms that have the same variable cluster until you don't have any other variables that have the same, or terms that have the same variable cluster. That's the main idea here. All right, now, generating equivalent expressions using the distributive property. Okay, we've done distributive property a lot. Sometimes it looks different though. All right, in this case, we're taking the first term here, or the first number, and we're multiplying it times what's inside the parentheses. So 6 times 2x, because remember when a number is next to parentheses, it means to multiply. All right, so 6 times 2 would be 12x. All right, then 4 times 3x, we would multiply 4 times the 3x, and then the 4 times the 2. So when I think of distributive, I think I'm distributing something out to the whole class. All right, everybody gets the same amount. All right, so everybody gets multiplied by 4 in this case. So 4 times 3 would be 12x, and 4 times 2 would be 8. All right, in this case, 5 times the 3xy would be 15xy, and then the 5 times the 2t to the second would be 10t to the second. Okay, see how that works? So we're just multiplying 3 times 5, and that's where this 15 comes from, and we're multiplying the 2 times the 5, and that's where this 10 comes from. All right, so let's try one together. All right, A. We've got 2, and then in parentheses, x plus 4. Okay, so what's outside the parentheses is this 2, and we're going to multiply each thing inside the parentheses by this 2. Okay, so 2 times the x and the 2 times the 4. So I'm going to get 2x plus 2 times 4 is going to be 8. 2x plus 8. And then I can't go any further because these are not like terms. So that is my answer. Okay? Now, let's take a look at another problem. Excuse me. Looking at C and I'm looking at F. I think I'm going to do F because it's got that fraction. That kind of looks scary. All right. It's tempting when you see these problems to just go crazy with multiplying everything by this number. I'll show you what I mean here. Okay? Because C is going to be the same thing here. All right? When I'm multiplying by this number out here, in this case it's 1/2. I'm going to multiply the 4x by 1/2, and I'm going to multiply the 2 by 1/2. But you know what? I am not going to multiply this 8x by this 1/2. Why? Because it's not in parentheses. Okay, it is its own little thing out here tacked on after we do all this. Because remember the order of operations? We want to do what's inside parentheses first, then multiplication, and then addition. Excuse me. So I'm going to multiply 1/2 times 4. Okay, now it looks kind of scary, but think about that. What is half of 4? Well, it's 2, right? So we're going to have 2x here, and then 1/2 of 2, oh, it's 1. And then, remember, I'm not multiplying this 8x by 1/2. It just comes straight down. It is not affected by this 1/2. All right, so that's what we have so far. 2x plus 1 plus 8x. Now I need to look for like terms. Okay, and I see that this has an x, this has an x, so I'm going to combine those two together. A 2x and an 8x would make for 10x, and then I bring down my plus 1. And then that's all the further I can go, okay? Because I cannot combine those two terms. So that's what the distributive property does. Okay, it takes what's outside the parentheses and multiplies it by everything inside the parentheses. Okay, I think that's where we're going to stop for today. All right, just want to double check though. Yep, That's it. So tomorrow we'll start on the next page. Thank you guys for watching. And as always, take care. And thanks for engaging the math. Bye.